You're working through a batch of documents that need to be reviewed and approved. You send them out, get feedback, make changes, and send them back again. Some are approved right away, but others go through multiple rounds of revisions. How many times will they loop back? How much does that rework slow things down? And how do you improve the process? There's a model for that. Welcome to Model Monday, a series where we break down scenarios in different industries, organizations, and departments, and explain how you can build a simulation of them in Process Playground. Let's model it. We're going to start by creating our item type. In this model, the item is called Document. This will represent each individual document moving through the process from creation through approval and final processing. Next, we'll begin laying out the process with blocks. Since this example starts with a fixed batch of work instead of ongoing demand, we'll begin with a queue block and name it Backlog of Work. This queue represents the starting inventory of work to be done. In this case, we want to begin the simulation with 40 documents to be created. So we'll add the document item to this queue and set the initial on-hand value to 40. That gives us a batch of 40 documents ready to move through the process. Now we can add our first activity block and name it Create Document. The backlog queue is holding work to be done, and this activity represents the actual creation of the document itself, whether that means writing, drafting, or filling something out. For the purposes of this model, we'll leave the processing time as a constant of 1 minute. We're keeping the time simple here so we can focus on how the structure of the process behaves. After the document is created, we'll begin building the first review loop. First, add a queue block to hold waiting work before review. Then, add an activity block and name it Review. This represents the first review step. We'll leave this processing time at a constant of 1 as well. After that, add a decision block to determine whether the document needs revision. This is the first point where the document can either move forward or loop back for rework. For the revision path, add a queue block and name it Needs Revision 1. Then, add an activity block and name it Revision 1. This activity represents the rework needed before the document can go back through review. We'll again leave the processing time at a constant of 1 minute. Then, connect Revision 1 back to the queue before review, so the document loops back through to the first review stage. Now that we've built the first revision loop, we can speed things up by copying that structure. We can use drag to select to grab the first loop, then use Ctrl-C and Ctrl-V to duplicate it. This is a nice way to build repeated sections quickly without recreating each block from scratch. After pasting the second set of blocks, place it after the first loop. Then, paste again to create the third set and move that one over as well. Once those copies are in place, we'll connect them together using connection lines. Then, we'll rename the blocks so each stage is clear. The second review activity will be named Additional Review. We'll call the decision block Needs Revision 2, and the second revision queue will also be named Needs Revision 2. The second revision activity will be named Revision 2. The third review activity will be named Final Approval, and the decision block will be named Needs Revision 3, and so on for the revision queue and the revision activity. The main idea is that the document goes through 3 review opportunities, and at each one it may either move on or be sent back for another round of revision. After the final approval stage, we'll finish the process. Add another queue block to hold approved work waiting for completion. Then add an activity block named Processing. This represents the final work done by the primary creator after the document has made it through approvals. Depending on the context, that could mean publishing the document, sending it to another department, mailing it, or otherwise completing the job. We'll leave that processing time at a constant of 1 minute also. Finally, add an exit block, so completed documents can leave the system. Now we'll go back and configure the decision probabilities. On the first revision, set the probability of needing revision to 0.1 and the probability of moving on to 0.9. On the second decision, set the probability of needing revision to 0.2 and the probability of moving on to 0.8. On the third decision, set the probability to 0.1 and the probability of moving on to 0.9. Process Playground will warn you if probabilities do not add up to 1, so this is a helpful place to double check your settings as you build. These probabilities are an important part of the model because they determine how often documents get circled back for rework instead of moving ahead. Next, we want to count how many times each document goes through revision. To do that, add an accumulator block. We'll name it Revisions. This label will also become the name of the parameter stored on each document item. Then connect the accumulator to Needs Revision 1, Needs Revision 2, and Needs Revision 3. For each of those, set the value to accumulate to 1. So every time a document passes through one of those revision queues, it adds 1 to the document's revisions value. This is what lets us later look at the item report and see how many rounds of rework each document experienced. Now, we'll add the shared resource that ties the process together. Add a resource block and name it Primary Creator. This one person is responsible for several different steps in the process. Create document, Revision 1, Revision 2, Revision 3, and processing. The review and approval activities, by contrast, can be treated as being done by other people who are effectively always available, so those review stages are not tied to this resource. That allows us to focus on how one constrained creator resource handles both new work and rework. Once those activities are assigned to the primary creator, we need to set priorities carefully. The main idea is to give work later in the process higher priority than work earlier in the process, so the creator does not keep starting new work while older work is sitting close to completion. The last activity should have the highest priority of 1, so work does not get stuck right before completion. So in this model, set processing to priority 1, revision 3 to priority 2, revision 2 to priority 3, revision 1 to 4, and create document as 5. The big concept here is that priorities run in reverse order of the process, so finishing older work takes precedence over starting fresh work. At this point, the model is complete enough to run. We're going to run the simulation for 100 minutes and watch the documents move through the system. At first, we'll see documents leave the backlog, get created, move into review, and in some cases, loop back through the revision path. If we slow the simulation down, we can actually watch a document enter one of these revision activities and then move back through review again. This is a good point to visually confirm that the flow is working the way we expect, and that the model is behaving logically before we move on to results. Once the run is complete, we can start reviewing results. First, double-click on the exit block and go to Results. A good place to begin is with Count and Total Lead Time. The count tells us how many documents completed the full process within the simulation time, and the total lead time tells us how long it took, on average, for the documents to move all the way through from start to finish. We can also look at the arrival pattern in the exit block and notice the small gaps that show up, where the primary creator was working in other parts of the process. This is a useful place to explore how priority rules affect throughput and completion timing. We can also take a look at the total lead time graph, which shows us a histogram of the amount of time it took for each item to reach the end. Then we can look at the queues. Double-click on a queue block and turn on metrics like count, average length, max, and even total lead time if that's helpful for your analysis. Then use Apply to all queue blocks so you can compare queues' behavior across the whole model. Looking across all the queues gives you a way to explore where documents are building up and where they are not. Next, we can inspect the activity blocks. Double-click an activity and turn on Count, Runtime, and Idle Time, and then use Apply to all activity blocks. This lets you compare how active each part of the process is and where your creator is spending most of their time. Now let's look at the revision counts. When we open the accumulator block, Process Playground tells us that the results of the block are visible inside the item report. So click View Item Report. In this report, we can see the individual documents and the value of the revisions parameter for each one. This is where the accumulator really pays off, because it lets us inspect the experience of each document, rather than just looking at block-level averages. From there, we can export the data into Engine Room for further analysis. Click on this button to send the data source to Engine Room. When we flip back to Engine Room, we can click on the data source and then edit and see the column of data that represents the revisions. We can even sort our data in the data editor. From here, we can do further analysis, such as creating a bar chart for the number of revisions. We'll go to the menu and open our bar chart, then click on the data source and drag the data representing our revisions over to the drop zone. Then we'll just skip through these options here, and we'll get to our bar chart, You can see that only a few documents had revisions, while most documents had 0. Engine Room makes it easy to visualize the data you generate in Process Playground. Finally, we can look at the utilization of the primary creator resource. The resource was utilized 93% of the time. We can also open the utilization graph to see how that work was spread throughout the simulation. That gives us one more angle for experimentation. So in a nutshell, that's the document revision model. But the real value is in what you can experiment with. By modeling how documents move through review and rework loops, you can see how repeated revisions impact cycle time and overall flow across the entire batch. And it's not just document reviews. The same pattern shows up in code reviews, design approvals, quality checks in manufacturing, or any process where work may need to be corrected and resubmitted before it's complete. From here, you can start to ask real design questions. How often does work get sent back for revision? How much does each rework cycle add to the total time? Should I improve quality up front or streamline the review process? Those are the kinds of trade-offs this model is built to explore. That's the model. Now go experiment. Happy modeling!